Hello everybody. I'm going to make one last video on this problem from my math lab that you see here. Quick summary of what I've done so far. I have this differential equation with this function as a proposed solution. And what I've done so far is I want to check that this function satisfies that equation. That entailed taking this function and working out what it is on the left-hand side, okay? And then on the right-hand side. All right, and that turned the differential equation into this. Now the issue with this last part is I want to show that this is true. I want to show that when I take this function and plug it into that equation, that I get a true statement. And this is not obviously true because this does not look the same as that. Maybe we can show that they're the same, but at least looking at it, they're not the same. Okay, so let me show you what is entailed here with this. Hyperbolic functions have a lot of identities, like trig functions. Okay, so one of the identities, and there are many, but one of them is that hyperbolic secant squared of x is 1 minus hyperbolic tangent squared of x. And I think that's the key to showing that this equation is true and that the left-hand side is equal to the right-hand side. Okay, so let's get to work on it. Let's take this identity as being true. I could factor out mg from each of these terms on the right-hand side. That would make the right-hand side RHS mg times 1 minus hyperbolic tangent squared of t root gk over m. But the identity applies to this. This is hyperbolic secant squared of t root gk over m. And then that's the left-hand side. So I can use this identity to turn the right-hand side into the left-hand side. Okay, and then prove that it's true. So that's what proves that it's true. Plugging in the given function that's supposedly a solution gets me this far right here, but I use this identity to go the rest of the way. Okay, so there are other identities with the hyperbolic functions. This is the one that's relevant for what we want, which is to show that this equation is true. On the problem on my math lab, it says, okay, hold on. Okay, on the problem on my math lab, it looks like this at this point. Which identity demonstrates the expressions from the two previous steps are equal? And so there it is. That's the way that the question is asked on my math lab. Okay, we reduce it to what I've showed you already. And then here are some identities for the hyperbolic functions. And this is the one that we need, right? Okay, so even if you were working this and you saw that this part came up and it was multiple choice, and you didn't know that identity already, hopefully you could see that it's exactly what we need to prove the statement that we have there.